When we talk about air pollution, we usually think of smoke, vehicles, factories, and dirty fuels. But what if the real solution lies not only in reducing pollution, but in changing the fuels themselves? What if the energy that runs our car, industries, and cities could actually help us breathe cleaner air? Today's guest is someone who worked exactly on this idea, turning future fuels into real climate solutions. We are joined by Dr. Kiran Piduru, an international recognized scientist in the field of green hydrogen, biofuels, air toxics, and fuel quality testing. Currently based in the United Kingdom and working across Europe, the Middle East, Africa, and India. Dr. Piduru began his academic journey in India with a background in pharmacy and analytical chemistry, and later completed his PhD in catalysis chemistry in the UK, focusing on advanced fuel system and environmental applications. Over the year, he has worked with some of the world-leading research laboratories, energy companies, and regulatory bodies on hydrogen purity, emission control, and VOC monitoring. One of his key contributions in his involvement in developing international testing standards for hydrogen fuel, including ASTM D7892, which is used globally to measure impurity in hydrogen, a critical step in making hydrogen safe and truly clean for transport and industry. Dr. Piduru's work goes beyond laboratories. He actively bridges science, industry, and policy, helping government and companies understand that even green fuels can carry hidden pollutants, and that without proper testing, storage, and quality control, clean energy can fail its purpose. What makes his perspective especially valuable is that he sees the problem from the both side of the world. As an Indian who understands the ground reality of pollution in developing cities, and as a UK-based expert who work within highly regulated clean energy system. In this episode, we will explore how green energy and biofuel can transform air quality, why fuel impurities matter more than we think, why India can learn from global clean energy practices, and how science behind the scene actually protect public health. Let's begin this future-focused journey with Dr. Kiran. We warmly welcome you, sir, to our platform.
Thank you.
In simple words, how can green fuel like green hydrogen and biofuel help in controlling air pollution?
So when you talk about green fuels, there are a few that are emerging. One of them is hydrogen and the biogas. And also they are planning to use carbon dioxide as a fuel energy. And these three plays a significant role when it comes to decarbonization, what we actually call as a net zero, targets for every country.
Obviously.
And they help a lot to reduce the dependency on fossil fuels, because if you see, that's where we're using a lot of fossil fuels, and we have a lot of potentially like pollution issues in India, especially here. And what that helps is the green hydrogen, for example, here, that will actually reduces the pollution for India.
Compared to petrol, diesel, and coal, what makes green hydrogen truly clear?
So when you see petrol, diesel, our normal everyday vehicles, what we do is we get a lot of VOCs out from the emissions, and that is actually causing a lot of secondary emissions and a lot of other problem. But with the green energies, what happens is the byproduct is just water. If you have a fuel cell vehicle like a car, and what the emissions that come out of the car is just water, water vapor. So that's a clean way reducing pollution.
So do green fuels really produce pollution on the ground level, or is it still mostly at the experimental stage?
As of now, I would say these are at experimental stage, but very, very high level. Like for example, there are hydrogen-based aeroplanes that are actually on prototype, which is in active. And also along with, there are some local commuting ships. They're actually working on fuel cells in Europe. So they are emerging, but it takes some time to be cost effective and also to enter into the market.
Why is BIS 5182 important in India, and how does it align with global standards?
So if you see what other countries are doing, there is a lot of EPA methods. Like for example, EPA, the TO15, which is a canister-based method, and also TO17 is tube-based method. And what they're actually doing is they're helping to analyze the air we're breathing in Europe or in USA, for example. And we don't have that dedicated method in India. That's where the BIS has released a 5182 part 27 and 28 recently to just initiate that similar kind of activity what other countries are doing and to analyze our air in better way.
So for my curiosity,
Sure.
I want to ask, what is BIS 5182?
It's that's a series of standard methods, which is, as BIS stands for British, Indian Standard Organization, and 5182 series is worked on environmental issues. So there is a lot of methods like part 1 to, I'm not sure, is part 27 or 26, I'm not sure, but everyone has a target of different chemical constituents, and these 27, 28 are primarily there are part 11 and 12, which has been replaced or revised versions of the earlier versions to analyze the VOCs in air.
No, I got it.
Yeah, thank you.
How does TD technology and BIS 5182 help stakeholders?
So it actually helps the stakeholders to analyze the atmosphere really better way. Because if you see the old methods which we are actually highlighting, 5182 part 11 and 12, they are based on very old technology of using carbon disulfide, which is very harmful, for human to handle. And this one is solvent free. These methods are really a sustainable way of analyzing these VOCs. And the technology itself will be helpful, not only this BIS 5182 standards, but also it helps a lot of other industries like automotive industry and material emissions, consumer product industry and stuff like that, just to understand what actually these materials are emitting outside. For a simple example is, we know as when we buy a brand new car, and when we open into the car, we just open the door, we feel a lot of smell that is actually coming in. Sometimes we like that, it's a brand new car smell, but actually it's a VOCs which we actually breathing. So there is a lot of regulation that are coming in place, which the thermal desorption plays a key role for analysis.
So we can say that BIS 5182 helps stakeholders practically.
Yes, that's right. They can implement this method, they can analyze what actually emitting from this material, and then they can take a proper protocol or mitigation steps going forward.
So why is testing hydrogen purity so important? Because using it in vehicle or industries?
Very good question. There are several classes of chemical components that are actually present in hydrogen fuels. So today, one of the key topic what I presented is how to analyze this key impurities present using the thermal desorption technology. And without proper analytical capacity or analytical method, we actually produce more toxics in the atmosphere. So that's why there is a fuel grade hydrogen like 99.97, so that is the highest level of purity you can get. So we need to use that high purity hydrogen to get an effective fuel cell or fuel vehicle. If there is 99%, for example, then the efficiency of the fuel cell, the catalyst present in the fuel cell, die very fast. So that is very important to analyze the hydrogen fuel impurities to have an effective vehicle and also to be more protecting environment. We don't want to release the toxics into atmosphere.
Hydrogen often used as a clean fuel.
Yes.
How does hydrogen play a role in pollution control and VOC reduction?
So it will play, it's not a direct role, I would say, but it will play some part of, mitigation protocols, because if you see, that's a part of decarbonization plan. We need to be reducing our use of fossil fuels. Like when I say fossil fuels, just take a simple example is fuel like petrol, diesel, and whatever we call intense. And this beauty of this green, I would say, is we need to have electricity first to have a green hydrogen. That green electricity can be produced by a wind or a solar that is free, like it's a completely green. And we use that electricity and then we split the water molecule into hydrogen and oxygen, and we're capturing that hydrogen and we're using as a fuel. So in this process, we're actually not depending on any fossil based fuel, so it's very clean. That's why they call it as a clean hydrogen, clean energy. So that is the beauty of it. We don't need to be rely on the carbon.
Yeah. What is your message to policymaker, industries, and research regarding VOC monitoring in India?
So one, it's a tough question to answer, I would say, in India especially, because at some point we need to start analyzing the VOCs, because let's look at to advancing countries like USA, for example, and you can take Europe as a kind of example. And recently there is a lot of implements in Malaysia, countries like Indonesia and our neighboring. I'm not talking about any other kind of. And a best example I would take is China, because China has implemented a lot of this VOC analysis method, and that became a mandatory for the routine. And it's not, they've only recently started implementing these methods, and they have seen significant improvement in the air they're actually breathing. So one kind of suggestion, or one thing what I'm expecting is we need to implement such stringent regulations, so everyone in India too. So that is the only way. It has to come from up, from like CPCB, or even our IIT institutes. They can actually start doing at research level, so that can be a guidance for all our researchers, for example.
Sir, can you briefly explain how scientists actually detect VOC impurities in hydrogen and biofuels?
So it's very simple how they can actually analyze these impurities. We have this technology called thermal desorption. And the beauty of this is they have a solid. I'll explain in a very simple, non-scientific way. And that solid has a capacity of absorbing chemicals. And what happens is when you pass a gas that containing these impurities across this solid, the solid will absorb all the VOCs or chemical nature of compounds present in that. And then when you heat that solid, then only it releases those VOCs, what has been captured in a simple way. So that is what the thermal desorption does. Whichever gas you're trying to analyze, we pass that to thermal desorption, whether offline or online. Then it gives you complete spectrum of compounds present in there. That's how we use this technology to understand more about chemicals and energy gases.
How has your work contributed to make these testing methods more accurate and practical?
So one of the key challenge for these fuels, energy gases, is the sensitivity, and that plays a huge role into understanding the energies and also to implement them in practice. So this technology will help you to improve that sensitivity of whatever detection you have in your laboratory. So that is what I would suggest, to implement this technology and to understand more material.
You are originally from India.
Yes, that's right.
And now you are working in UK.
Yes.
What is the biggest difference you see in both countries deal with air pollution?
Okay. A simple example is I would take AQI. That is one of the simple parameter where everyone kind of assess. And if you see where we are sitting with the AQI and where the UK, that's where I actually residing as of now. And the AQI in last week, for example, is around 2.
Around 2?
Yeah, 2, 3, 4, depends on where you travel. And here is 400, 500, or 4, something around higher region. So there is a significant change, when we come. Whenever I feel to go to Delhi, for example, I feel there is something in my mouth. Something I'm breathing is not correct. But again, it's a different nation, different grown nation, and they have very clean. They have very kind of green systems, I would say. So it's different way of living.
So as per your perspective, how can we manage this?
How can we manage? I would say a stringent regulatory bodies has to come in India to have a strict regulations, and we need to implement those methods. It's not like buying one equipment and keeping in your lab, for namesake or something. We need to utilize the technology, and we need to understand about what kind of air toxics that we are actually breathing. We need to have a similar kind of strategy where USA, Europe, and even China, for example, how they implemented. It's all available online. And what
which type of strategies?
So we need to analyze the air at the different hotspots. We need to understand the sources of emissions. For example, if there is a very, very polluted area, then we can go and take the sample and analyze. We know who is actually releasing these VOCs. For example, if there is any X company actually producing X chemical, And if they're releasing that into atmosphere, we can easily calculate how much actually they're releasing into atmosphere. And then that is where I'm stressing is a stringent policies that, once we analyze, what is the next step? How we actually reduce the emissions into atmosphere? And then we can make a request to a particular institute and say, guys, yeah, you're releasing so much into atmosphere. Is there anywhere you can condense, or everywhere you can, avoid this into? So that's how first thing is analyzing, and then second step is to implement some strategy, how to reduce that emissions.
What are the best practices India adopt from UK and Europe?
You're talking about pollution-wise, or okay? That is where Caroline shown a lot of data today in the discussions what we have today. They have very well established network. For example, best example is the PAM station. There are around several number of the stations across the USA analyzing the data every 1 hour, and then they're sharing each other. So that is the good way of understanding our country. So what we do is at least we can hotspot maybe 10 cities in India, and then we have these monitoring stations in these 10 cities. At least we can share the data which region is more contaminated, or and then we can take a proper step.
And it started from Delhi.
Obviously that is one of hotspot, I would say.
Do you think India can realistically become a leader in green hydrogen?
Yes, it is a lot of potential. India have high potential in this firm. I've been a lot of hydrogen conferences in India. There is a lot of technology providers available. One thing is I see the key difference I see from here and the UK is the sun in UK is not that frequent. We get like 6 months sun and 6 months winter. Here we have sun all the time, apart from the rainy season. But why don't we use that renewable energy and then use water everywhere? Let's do water electrolysis, for example. So there is massive projects coming into India for mainly on the hydrogen. I see India will boom when
if we use renewable energies.
Yeah, that's correct. Yeah.
Your journey from India to becoming a global expert in air. Air toxic is inspiring. What was the turning point in your career?
So, apart from my job personally, I travel a lot of countries, during my career and off the career. For example, I do appreciate a lot of tradition, a lot of culture. But one thing I want in India is to have a better air, I would say. That is what we are missing. But again, that comes down to how we implement this technology, or what is the mitigation steps to take forward. How we can improve the air quality in India will be one kind of challenge.
What advice would you give to the young students who want to enter the climate energy or climate environmental science field?
Very good question. We have very bright institutes across India. We have IIT campuses here. Every city is we have very bright kind of academics. And one thing is we would like to start from the research level, because this technology is not only for from policymakers, or this is not for some kind of industries. This can be implemented at academic level, even at a master's degree level. So as of now, these technologies are not implemented at academic levels. So it's very good today. We have some DTU people like Delhi Technology. A professor was here and he's asking a lot of questions how this technology works and stuff like that. And also I spoken to a couple of students who is actually doing solvent extraction. Again, it's a very old, like 80s kind of method. But one thing I would say to the younger generation is just get advanced ourselves, what other countries are doing and what impact that actually had, on that country. So there's a lot of open literature. You can see now AI kicked in, ChatGPT is there, you can ask all the questions, this kind of thing. So I would ask to utilize the technology, whatever technology is available, to improve our country.
You use AI and ChatGPT, then I remember a question.
Yes, sir.
What was your perspective? AI is job threat or opportunity?
It all depends, I would say. There are some regions where AI really helps to make human life easy. And there is also some sectors where it actually damages the human,
lazy as well.
Yeah, they're lazy as well. Again, we have to monitor, we have to restrict. especially I have my baby, and I always restrict her to use from social media,
Yeah,
for
AI.
example, AI kind of based platforms. But yeah, it's a personal choice. But there are positives and there are also negatives
Negative.
along with any of the other
Yeah.
things. Yeah.
At last,
Yes.
if you had give one message to policymakers, scientists, citizens, together about clean energy and pollution.
Yeah.
So what would be?
So one thing I would say is civic sense. We need to be a little bit better.
Yeah.
And one simple example, this always sits in my mind, so I want to share this one with all the open people. I was in Shanghai in a train, and there is a 11-year-old little baby, and I was watching her because she was hugging her dad,
Yeah.
and she was standing and journeying with me. And the one thing actually caught my attention is she took a pack of chips. You know. She opened it, she had that complete pack, and then she had a banana. She finished her banana, and she opened a waste bag from her
Yeah.
backpack, and then she actually tied it. And after, I was really amazed, that 13, 14-year-old. And then once she got the train, she went out and she put the plastic into plastic waste, and then the food into a wet waste, which amazed me. So I would like we all also take that as an example. And recently I was traveling, and I seen some people splitting pan. Some people are throwing this groundnut shells, for example. This all comes down to
so we can say that it's all about awareness.
Yeah. And that's what I would suggest. We need to be more sensible.
Yeah.
We need to be watchful of others, whoever is next to us. We need to respect each other, and we need to respect the nature. If you're not respecting the nature, I don't think there is any civic sense, in the people. I think you might seen a lot of videos recently on Instagram and on LinkedIn, and India has been kind of highlighted in some of the events. Say this video, that kind of it. I would be suggest to be more sensible and respect each other.
Thank you so much,
Thank
sir.
you. Yeah.
Thank you so much, sir, for your valuable
No problem. Thank you.
time and give your expertise to our audience too.
Thank you very much.
Thank you so much.
Thank you very much. So, good morning, everyone. Before I start, I would like to thank Jay Sharma to be a guest today, and also the NPL experts who are here with all the academics. I know everyone have their own expertise in here. And yeah, today my topic covers how we can actually analyze these key impurities present in the green energies, whatever we call today. And I will also cover the impurities and standard compliance, how you have to compliance to the methods, and how you can actually achieve the compliance with method. And I need to thank Dr. Tyagi. He's just instrumental in explaining the technology, but I'll go in between who we are actually, who is Marks International, and what actually we do. We've been in this VOC kind of analyticals for last 28 years, and we are one of the pioneers analyzing the VOCs in any metrics. Like if we have liquids, solids, and then any material emission kind of analysis, we kind of supplying all the application across the globe. And we can see the map. There are some dot points there. We have 2 sites in USA, and we have 2 in UK, and we have in China. But also we have indirect channels working across the globe to support various applications and also various customers. And one of this beauty of this instruments, what I'm going to showcase today, is they are certified for use of hydrogen, because it is a flammable material. We need to consider its safety when you are actually handling and when you're trying to analyze in your laboratory. So with that, I'll just go into introduction of why hydrogen, why we are here talking today. And as we know, not only India, there is a lot of other developing countries. One of the challenging we have is the pollution control, and that is a part of decarbonization or net zero. This is the terms what we actually been using or hearing a lot recently. And when you see into how we can reduce these emissions, one of the kind of task is to find a clean energy, how we can actually reduce the emissions from different sources. So this hydrogen has that tendency, capacity to cover a lot of gaps. For example, it can be a fuel, to logistical kind of transportation. It can be fuel for a raw material like a green ammonia, for example, or green energy like green ammonia, green methanol, that can be used as a fuel for the transportation. And also it's versatile. You can use in steel manufacturing. We can reduce the emissions through the fossil kind of dependency, and it is a sustainable kind of a fuel for a long-term growth of any nation. And yes, again, Shankar Agarwal has shown very nice data, and he's shown the methods earlier. What is impact of this key impurities present in the hydrogen electrolyzers. So what happens is, if you not analyze these impurities, what you're going to do is we end up producing more impurities from the fuel cells, because there is a grade that actually set up is 99.9. So there is a reason why that high grade fuel hydrogen is required for the fuel cell manufacturing. And if you don't analyze them, we are into trouble. But again, I will come back where these impurities are actually coming from. What are the different sources of these impurities present in the hydrogen fuels? And we can see here, I stated some of the methods of producing hydrogen, and one of the top will be the steam methane reforming. What it is, 90% of the hydrogen currently produced across the globe, and they call it as a gray. There is rainbow colors of hydrogen across, depends on the source, how they actually generated, and the gray is the leading. And there are 2 or 3% from the coal gasification, and also it's a byproduct from HCl production or chlorate industry. And again, as of now, as we're speaking, the green energy or green hydrogen only accounts for 1.2. It's less than 2%. So there is a lot of growth. There is a lot of technology improvements which we need to get to have the hydrogen as a fuel, for the green hydrogen as a fuel. And it's not only when we generate them, the purity of hydrogen is around 80 to 90%. So there is a lot of purification technology which we need to impact, like there is a pressure swing technology, there is a membrane technology, which in practice to remove or to improve the purity of this hydrogen. And again, yes, there is a technology, but also there is a potential that we might also include a lot of impurities when you're doing the purification process. Yep. And again, after when you purify it into some form, transportation is a challenge, because I'm making this hydrogen at one city and I want to utilize in a different city. How do we actually transport? Because it's very light. We have to compress them, and also compression process, may add potentially some impurities. And with the logistical, in countries like Europe, it's already been implemented as a fuel for cooking. For example, it's been used as a blend gas for normal CNG, for example. Again, they're using a standard gas pipe network. So we need to check about the compatibility, whether the hydrogen, if there is any greases or if there is any kind of impurities present in that pipeline, hydrogen acts as a very good stripper. So you're going to strip all the impurities present in the pipeline. Again, we will be carrying out in your supply chain. And the end product, we see in the fuel cells. Fuel cells are very sensitive. We can see they can get damaged very quickly if we are not using high quality of hydrogen as a fuel. So we can see there is a lot of potential chances of adding these impurities. It's not only at the production site. It maybe we might add as at the use point of thing. Sorry. And let's talk about the compliances. What are the compliances method? And already Dr. Shankar Agarwal has highlighted 14687. It's a global method which has been kind of implementing. It's been working in different parts of the globe, but also there is a indigenous methods that they are actually looking, like GBT is a Chinese equivalent of 14687. They have this list of impurities they need to analyze and they need to control to be compliant for the local legislation. And yes, 14687 is a global reference. Again, there is a USA dedicated one for the transportation sector for SAE J2719. But it is the conclusion for this slide is they all speak the same language. They all reference to the same list of components, and it also have the same list of limits. Okay, sorry. And these are the list. These are the suite of the impurities that you need to be compliant with, and I won't go into all of them, but I will just highlight the key impurities that we have to be mainly concerned about. So hydrocarbons, for example, and again total sulfur molecules, which is 4 ppb. And it is, when we're talking about ppb, it is we need to have a very sensitive system. If you are ppm, it's okay, we can easily analyze them. And if you're talking about ppt levels, then we need to be super cautious, like what we're actually analyzing, what we're actually capturing, and this kind of thing. So 4 ppb of sulfur is a challenge for a standard chromatogram, because these molecules are unstable, they are very sensitive, they get degraded, or they convert into different form when they hit a active site where there is some acidity or basicity. And also formaldehyde, aldehydes are very sensitive, and they are also very non-stable. They transfer into para forms and some different form. And halogenated, again, there are a lot of halogen, they can be very active. And those are the methods. If you are particularly concerned about, or if you're particularly interested in halogenated molecules or hydrocarbons, there are dedicated methods that are actually covering these impurities. For example, ASTM D7892, that is one of the standard. I've been working for last 2 years, and I'm one of the technical committee member for that method. And what it aims is, it aims to analyze total organic halides and total non-methane hydrocarbons and formaldehyde in hydrogen fuels. So they have listed what are the hydrocarbons, what are the halo molecules you need to be analyzing to be compliant with this energy fuel. And again, all these methods, as we highlighted here, I can share these slides to all the participants, so you can have this reference. And today's topic is, I don't want to go in depth in technical. As Dr. Tagi mentioned, we can pull all this air into a balloon. That's what actually pre-concentration means, because this air is so big, there is a few hundred liters of air, and if there is 1 ppt or few ppbm particle hanging around, we need to concentrate that to increase our sensitivity of detector. So that's what the thermal desorption actually does, that improves the sensitivity. And why we need this thermal desorption? One thing is, basically the outline is it increases the sensitivity several hundred times, because the standard GC on a benchtop, it is not having that sensitivity to go into the compliance method. But like, for example, I would draw a line, if any standard GC, maybe 5 ppb will be the kind of the lowest. Even we are going to few ppbs, like 2 ppbs, we struggle with the peak shape, we struggle with the sensitivity and stuff. So that's where a standard GC is not compliant for some of these methods. So you have to be, TD is mandatory to have into that compliance. And this gives a flexibility, this gives the versatility of the sample collection. You can collect the sample on a sorbent tube. So when we say sorbent tube, what actually it is a size of a pen. It have a solid inside. It can be a polymer, it can be a graphitized carbon, it can be even, sometimes it can be wool with some tenax kind of thing. And what it does is, it will, when we pass a gas through that sorbent, it actually absorbs whatever the VOC is present in your sample, and it's only releases when you heat the tube. So very simple technology, and that's how we do pre-concentration using this technique.
How do you address the saturation limit of the tube?
I will come after this discussion. And there are certain limitations, what we can actually do and what we can't actually do with the tube and online system. When I say online, it is you collecting the hydrogen is a gas bag or a cylinder or a canister. When I say offline, I'm just collecting the tube by hydrogen by a tube. So let's look at the data, how it looks like when we're doing an online canister kind of analysis. What we're looking here is a 62 target compounds, a mixture of hydrocarbons, halogenated molecules, and aldehydes, for example. And this is how a standard chromatograph looks like. It's a bit complex because there is a lot of components which you're trying to analyze. And as I said earlier, we can use the hydrogen as a carrier gas, because the earlier slide is using helium. Now with the hydrogen, we can ramp up the speed. Like we can see there, it's in 13 minutes we can get an analysis for each sample without losing any sensitivity. And you can look at here, I always talking about the sensitivity here. We can see 0.25 ppb to 20 ppb we are talking about at the calibration curve there, and with the regression coefficient like R square 0.999 is we can tell the sensitivity or the calibration range. And this is for the halogenated, this is for a sulfur soot molecules, again at very low concentrations. We are looking at 2.5, repetition of 9, we are getting RST 3.57. Again, it confirms the sensitivity of the system. And aldehydes here, two aldehydes which we focus here is formaldehyde and acetaldehyde, just to show you the sensitivity and the reproducibility of the system. And again, if you are going into sulfur, because sulfur species is very sensitive, as I explained, they are very tricky to analyze, and there is a dedicated detector like chemiluminescence detection where we can go into ultra low quantification. And this is a suit of 9 sulfur molecules at 1 ppb concentration. We can see at 1 ppb this has very nice sharp peaks in here. And to go into further down into the sensitivity, what I have done is we run at 50 ppt. So this is the chromatogram what you are actually looking using the SCD. And with the SCD, the beauty is we just ignore all the other hydrocarbons. It's just focused on chemiluminescence sulfur detection. And again, to go further down is 20 ppt. So this is the capacity, this is the beauty of the system. It goes to ultra low to get that compliance with the key hydrogen standards. Now we look into the sorbent tube, how the data looks like when you're trying to use a sorbent tube, and then you sampled a few liters of hydrogen. And it's very simple, just flow through at using 50 ml per minute and collect a few liters onto the sorbent tube, and then just add on to automation TD system, and you get the analysis. It's very simple kind of platform. And what we are looking here is again that 62 compounds range, but what the added benefit of sorbent tube is we can extend the carbon range from C14 to C40s, like whatever, if there is any waxes present in there, whereas there is any greases present in your hydrocarb, like this hydrogen fuel, then we can get this very exactly quantified. So it's combination. If you ask me a question, well, how do you actually analyze the hydrogen fuel here, whether you use a sorbent tube or a gas bag, or it's a complementary, I would say, because if there is any we get a lot of inquiries from different manufacturers to analyze, and one of customer in Germany, he's getting some greases like oils from the hydrogen facility, and we actually help them using a sorbent tube, because that one will stuck in a canister or a gas bag. It's not going to be movable. And that's the kind of hydrogen. I just want to quickly cover some of the biogases, like what are the other energy gases that market actually is looking today. So biogas is one more candidate that actually caught the attention because it's the feasibility it have, and I'm not going in depth into the methodology here because I'm lack of time, but I can cover it and I can provide as much information as I can give you. And also this speaks the same language. It's also covering the same kind of impurities and the same classes of molecules in here, to not as low the fuel grade quality, but again they are one. Yeah, sure.
It is mg per metric.
Yep.
Why?
Yes. Yeah, it's not as sensitive as hydrogen. Yeah. And again, the biogas is slightly behind when it comes to energy gases. Again, there will be a bit stringent regulation will come down the line, but this is the European standards, the technical committee they are actually working on. And again, if you look at the CO2, which they are again talking about carbon capture and storage utilization, they also sit with the same range, like high concentrate, like not very low. And one concern with these biogases is the siloxanes. This has been kind of issue, and there will be transformation from L and D kind of molecules. And what we have done is recently we have done of these samples analyzed by using TD, and they're also the European group, the No Lab. What their expertise is in they analyzing the biogas in various form, and they used our tubes, canister and gas bags just to analyze what is the variation between L and D molecules here, which is the best technique to get better analysis. So all them tube, canister, gas bag is all worked for this type of analysis. And again, I just want to show you how actually the systems looks like. This is a typical kind of a platform. What we're having here is we have the black box there is called Ultra. That is a 100 tube auto sampler, And then there is a Cori, which is for removing moisture. If your sample is so moisture, or there is a high content of moisture in your sample, we might lose that polar molecules because it adheres to that polar nature molecules. So we need to have a Cori. How Cori works is it actually removes the moisture in form of ice, because it is trapped at -30 degrees, and then all the volatiles passes through the trap, and we get a better analytical sensitivity. And then CA advantage, that's a lost corner box. What it does is it does automation of the canister or gas bag. And if you're trying to have a combined project, you're trying to analyze the hydrogen with a solvent tube and also gas bag or canister, we can do the automation using a single system in a single sequence. So that gives the added advantage of combination. And I'm not covering much of CO2, but this is a one system for a multiple platform, I would say, because what we are actually doing is, in single system, we have a focusing trap inside, and that is a key part of it's a heart of the thermal desorption, where the analytes gets kind of concentrated. And by just changing the trap nature, we can completely change the use of the system. Like if there is for today, it's ambient air monitoring. I want to analyze PAMs, or I want to analyze like HAPs or whatever molecules. We have a dedicated solvent which we recommend, like a PAMS focusing trap. We can put that one. And if you're slightly changing a project to hydrogen fuels, it's as simple as that. We just change the trap. And we have multiple systems, instruments, depends on the project, depends on application, and the product starts from a single tube. If you want to just try as technology, and if you want to compliance, we can get a single tube, but we can also goes to 200 tubes automation, for example. Again, if you have any queries, myself and Caroline will be here after lunch. Please feel free to grab us and extract as much information as you can today. And I want to also give you some examples, okay, what the other institutes are doing with these systems and where the systems are. And we have NPL UK, and they are analyzing a lot of projects with Europe, and one of the kind of project initiation is to analyze if there is any contamination of high hydrocarbons that are present in the logistical so they have in UK, and the VSL in Netherlands, they're actually one of the similar kind of metrology group, and they provide the calibration checks and standards, and then they do have the CAA, the canister type of system for hydrogen fuel implications. And Hydrogeneous in Germany, they actually use or support a lot of logistical projects, and what they're trying to do is they will do the hydrogenation using this liquid organic carriers like benzyl toluene, for example. They do hydrogenation reaction, and they store hydrogen into this benzyl toluene. They transport the hydrogen in liquid form, and they do dehydrogenation, release the hydrogen. So there is a lot of safe mode of transportation, and during that hydrogenation and dehydrogenation, there is potential that this benzyl toluene gets saturated in the hydrogen. So what we can do is we can analyze that saturation levels in there. And Sinopec Beijing, they've been doing a lot of these green projects. For example, we had one of instruments. And there is Movi, he's a CEPSA in Spain. They have one of the biggest hydrogen production site. And also they have R&D, both have the CAA canister-based system, which is in use. And also Bureau Veritas, it's an analytical lab. They have a very big facility to analyze or support a lot of customers across the globe. They have a complete suite of hydrogen method compliance system. So yeah, I just finished just to cover pre-concentration, like whatever the technology I'm showing here, the thermal desorption is required for the compliance of these green energies, because with the standard gas chromatography we can't reach to that like on low concentrations. And also, as I mentioned, we have the flexibility, the sample strategizing, and also the workflow. It is very easy, and we can modify these projects for different applications. And coupling with the SCD, yes, the sulfur will be an issue, because we hear a lot of this instability, and also we don't know where they're actually produced within this hydrogen supply chain. So yeah, with that, I just will cover most of the discussion today.